All right, here's the video on the circuit that I posted earlier today on Facebook. Now, if you don't really care about electronics or technology or the crazy shit that I build, move on because it's only going to get worse from here. But if you do care, stick around. So here's what it is. Here's the final version that I posted. Now, I'll explain a little bit about what it does in a second, but I thought I would explain the project first. This was the original prototype that I built, and here's the circuit diagram, and here's the wiring diagram. But more importantly, right here on my cell phone is the actual product that it's going into. So a couple guys out in Washington reached out to me and said, and these are just guys I don't even know. They just reached out to me because of something I posted online over in Instructables and said, hey, we're building these trophies for a car show and we don't know how to do the electronics. You seem to know what you're doing. Would you mind helping? And I said, sure, why not? And so they sent me this. This is a picture of the trophy. And I believe, well, there's 3 of them, and I believe they're all the same. I think they're just changing the best in show, first place, second place, third place, or something like that. But anyway, that's the prototype that they built out. It's a tail light from some car. I don't know anything about cars. There's a switch in the middle where it can go from like a flash to, I don't know, kind of like a flicker or something. I'll show you what I did here in a second, and the final version might change. But anyway, they built this, and they said, hey, could you work with us to build some electronics on the inside? So that's what this is. I originally built this little prototype up in order to see if I could get it to kind of work with the way they wanted it. Sent them a quick video on that, and they said, yep, that looks awesome. And then I soldered this up here yesterday or last night and finished it up this morning. So what this does is, I'm going to just go ahead and move this out of the way. So what this does is, I'll just pull the circuit diagram in, since I'm sure all of you guys can follow circuit diagrams, and it's probably self-explanatory. I'll zoom in just a little bit. There we go. So I built this around an Arduino Nano, which is this guy right here, the super small microcontroller. And what I wanted to do, because it's going to be behind that lens, is I wanted to get kind of as many LEDs in as I could. So I did 4 3-in series LEDs, and that's what we have on this little board here. So there's 4 groups, 3 LEDs in series, and then I've got some 100 ohm resistors in here as well. And then this is powered from our buddy, the 9-volt battery. So this is actually 9 volts running through each of these. And the microcontroller will work fine on 9 volts because it has a voltage regulator on it, but it's normally a 5-volt microcontroller. So what I've done is I've got that little module here, and then I've got the 2 wires that are connected to it here. And then the microcontroller, because we have 2 states, we have a flash and then we've got a flicker. What I ended up doing was running that 9-volt through the switch and then through some diodes back to VCC. So depending on which switch is flipped, actually, if either switch is flipped, it'll power the microcontroller. But it also goes through this resistor divider, one for each of them, each of the 2 parts of the switch, and that goes into 2 digital pins. Now this is going to be, give or take 4 volts, 4.3 volts, something like that, depending on the charge of the battery. It could be as low as maybe 3.5 volts, but it doesn't matter. It's enough for the microcontroller to pick it up as read. Now I can read which of those 2 switches got switched, whether it was kind of in the up state or the down state. And then I can do whatever I want in the microcontroller. And I'm not going to bother to show you the code, but if you're super interested, go ahead and comment below and I'll send it to you. Anyway, the code goes through, determines which switch is on, since it can only be one. It'll then just loop that pattern indefinitely. And then it uses this little transistor here in order to switch the LED cluster on and off. So anyway, that's it. It's pretty straightforward. Even if you don't know a lot about electronics, you can kind of see the general idea of how that works. So I'll set these here out of the way. This is then the initial prototype. I don't actually have a double pull, double throw switch. I know it's weird, but I just simply don't have one. I had some other weird switches, but I ended up just making up this little switch here just on the initial prototype. But this, and then I had the lights plugged in here and the battery plugged in over here. But as you can see, kind of a little bit of a rat's nest of wires in order to get it all to work. And then what I ended up doing is drafting that circuit out on a little kind of how I'm going to organize the components on the little PCB board or little perf board. And so this is what I ended up coming up with from a design on that. We've got our switch over here, going through those diodes into VCC, resistor dividers back to the pins. And then over here's our transistor, as well as our LEDs and our 9-volt battery. And then because this gets soldered on the bottom side, it's kind of reversed. So I'm actually soldering on the back side. I then just flipped this piece of paper over, redrew those traces on the back so that it was the right orientation, and then I went ahead and built this little board here. I'll go ahead and zoom in even further, although I know the quality drops pretty quickly when I do that. And this is what the final version looks like. Over here I've got just 2 little Molex connectors, one for the LED module that I showed you earlier, and then one for the 9-volt battery. I just drew with a Sharpie on this one so that we could tell them apart. Here's our transistor, resistor on that, and then here's our resistor dividers and our diodes right here, controlling the power. And then I literally just sandwiched that in on the pins of the Nano, and then I just soldered a couple of them. So, well, I soldered the ones that have connections, then I just soldered a couple of others. So you can see it's really, really thin, and it's really tight, really nicely well laid out. And then this wire I literally just have soldered in and then pulled out the back side. Now this end, I'll go ahead and zoom back out. This end will actually go to that switch, but since I didn't have one, I just put that connector on, and then I'll just send this connector, and they can hook the switch up themselves, crimp it, solder it, whatever. And then this is also a module. So right now what I'm doing is I'm just using this piece of jumper wire in order to simulate them turning on and off. So let's just turn it on. I forget which is which. So the first mode, so this is going to be I think this is this is the flicker mode. So this one, actually let's do the other one first. So this one's just a on off, what did I do? 2 seconds on, 1 second off. And so it's just kind of a blinking light. And it's actually super bright. I'm not going to shine it up at the camera because it'll just flood it out entirely. But with all those LEDs, it is pretty bright. I think it's going to work really well through that lens. But what this does is it does a real quick ramp up to full capacity, and then it's on for 2 seconds, and then does a quick ramp back down. So if you think of like a brake light, which would be in general from an older car, an incandescent bulb, where it kind of has that on off where it kind of glows for just a fraction of a second. So that's kind of what I was trying to emulate there on this mode. And that's all it does. It just flashes forever. Now let me flip it to the other mode. And this is kind of a flicker mode, or I don't know, maybe it's a broken brake light mode. So it goes on and it kind of ramps up pretty quick. And then it goes into this mode after 5 seconds where maybe that light is burning out. And it's just kind of arcing, and it eventually goes out. And then it goes out for 5 seconds, and it repeats that pattern. So it's kind of simulating maybe what you might see on a broken tail light, kind of in that weird flicker state. So I'll just let that run here 1 more second. It comes back up real quick. It's on for 5 seconds, and then it kind of stampers around a little bit, and then cuts out. And then it goes out for 5 seconds, and it'll just loop that indefinitely as well. So anyway, that's the project. I know you guys were super, super curious on it. If you stuck around for the whole video, awesome. Congratulations. That's all I got. If you got any questions, let me know. Or if you want me to build you one, I'll build you one too.